All right, let's picture this. Your Python project. It's taking off. That little proof of concept is getting real traffic, which is an awesome problem to have. But that simple SQLite database you started with, the one that was so perfect for getting off the ground, well, it's starting to buckle under the pressure. It is definitely time to upgrade to a real production-grade system like Postgres. This is a journey almost every developer makes, but it's a road that's absolutely littered with hidden traps. Today, we're going to uncover them.
The best way to think about it is like this. SQL is your super forgiving friend who helps you tinker in the garage. It's flexible, it's easy, and it doesn't really sweat the small stuff. It's just perfect for prototyping and getting ideas out there fast. PostgreSQL, on the other hand, that's the strict, by-the-book professional running a certified factory. It is built for production, it demands absolute precision, and it enforces strict quality control on everything. Every piece of data has to be perfect.
And here's the kicker. If you're using a powerful ORM like SQLAlchemy, the whole migration seems like a total piece of cake. I mean, you just go into your config file, change one little line, the database connection string, and you're good to go, right? The ORM is supposed to smooth over all the little differences between the databases for you.
So you're probably asking yourself, how hard can this really be? And, that is the exact question that has tripped up so many developers. Because what looks like a simple flick of a switch, well, the reality is a whole lot more complicated. Welcome to what I call the migration minefield. This is exactly where that simple one-line change just blows up in your face. And the reason is pretty simple. SQL's easygoing nature lets you get away with all sorts of things that the strict professional Postgres will just flat out refuse. You're about to discover problems in your data that you probably never even knew you had.
Okay, so the single biggest trap, the silent killer in this whole process, comes down to how these databases handle relationships between your data. It all revolves around something called a foreign key. That's just a simple rule that says, for instance, a blog post must belong to a user that actually exists. It's totally fundamental for keeping your data sane.
And here it is, the bombshell. By default, SQLite doesn't actually enforce these rules. It'll happily let you create what are called orphaned records, like, say, a blog post that points to a user ID that doesn't exist anymore. Your app might seem to work just fine, but under the hood, your data is slowly becoming a mess. PostgreSQL will not let this slide. You don't have to take my word for it. As developer Philip Mularchik puts it, this is the classic nightmare scenario. You have all these data integrity problems you never even saw while you were developing with SQLite. The second you try to load that data into Postgres, bam, the migration fails. Foreign key violation. Game over. Here's another classic pitfall. String lengths. So, in your code, in your SQLAlchemy model, you might say a username can only be 50 characters long. SQLite sees that and just completely ignores it. It'll happily accept a username that's 100, 200 characters long. But Postgres, our strict professional, it enforces that 50-character limit religiously. The moment you try to import that oversized data, you get an error. And the fun doesn't stop there. The very way they talk about data is different. In SQLite, a Boolean is just an integer, a 0 or a 1. PostgreSQL has a real true-false type. SQLite stores a date time as just plain old text. PostgreSQL demands a very specific timestamp format. So data that's perfectly fine in SQLite needs to be transformed before PostgreSQL will even look at it.
Okay, so we've mapped out the minefield. It sounds kind of scary, right? But the good news is there are some very well-worn paths to get you safely to the other side. Let's look at 3 main ways you can tackle this migration.
So your options basically fall into 3 different camps. First, if you're using a big framework like Django, you can use the tools it gives you right out of the box. Second, you can grab a powerful, specialized external tool like pgloader. And third, if you want maximum control, you can roll up your sleeves and write your own custom Python script. For all you Django folks, the framework gives you a pretty clear step-by-step process. You start by using dump data to pull everything out into a big JSON file. Then you point your settings to the new PostgreSQL database and create the new table structure. But here's a key step a lot of people miss. You have to clean up some old metadata first. After that, you use load data to bring it all into its new home. Next up, PG Loader. Think of this as the heavy-duty power tool. It's a separate program designed to do exactly this job. It can automatically figure out your database schema, handle a lot of the type conversions, and move data really, really fast. The catch? Well, it's not a Python library, and if you look around online, you'll see a lot of people mentioning that it can be buggy, sometimes it just crashes, and it has some known issues, especially on Windows. But for that ultimate level of flexibility, nothing beats just writing your own Python script. And you've got a few great ways to do it. For a pretty straightforward transfer, using SQLAlchemy Core to read and insert data in chunks is a great choice. If you know you have messy data that needs cleaning up along the way, Pandas is your best friend. And if you're dealing with a massive data set and just need raw speed, exporting to a CSV and using PostgreSQL's superfast copy command is the way to go. So now we know the problems and we know the tools. Let's put it all together into a pro-level playbook. This is your checklist to make sure your migration is as smooth as humanly possible. And to avoid all those frustrating failures. Before you even think about moving a single byte of data, run through this pre-flight check. Step 1, always, is make a backup. No excuses. Then, go looking for those exact problems we talked about. Long strings, orphaned records. Make your development SQLite database stricter to catch problems earlier. Then, after you create the empty tables in Postgres, test the entire process on a staging server. That is the golden rule. Okay, listen up. If you remember one single line of code from this entire explainer, make it this one. Add this pragma command whenever you connect to SQLite in development. It tells SQLite, hey, start acting more like Postgres. Enforce those foreign keys. This one line will save you so many headaches by helping you find and fix data problems as they happen, not during a panicked production migration. So the data is moved. Great. But you're not done yet. Now you verify. Check the row counts. Spot check the data in a few tables. And this one is huge. A lot of people miss it. You have to reset the primary key sequences. If you forget this, the very next time your app tries to create a new user or post, it'll fail. After that, rebuild your indexes for speed and run your entire test suite against the new database. I'm going to say it one more time because it is that important. And the quote says it all. Never, ever, under any circumstances, should you run your migration for the very first time on your live production database. You have to test it and test it and test it again on a copy. So as you can see, moving from SQLite to Postgres isn't just a one-line code change. It's really a test of your data's integrity. It's a rite of passage. But by knowing about these pitfalls ahead of time and preparing for them, you can turn what could be a total disaster into a smooth, successful upgrade. And that leaves us with one final thought. Knowing everything you know now, how are you going to set up your next project to make this journey even easier?